can I now invite educator Ashwin Guha to please, who is also the author of the homework, to give us a very interesting take on mathematics.
My name is Ashwin, and I am a maths teacher. And I am also an author. I have written this book, The Homework. And today I wanted to give a talk. So, the brief that I was given, it was kind of overarching and very wide. That is, what are the stories? What are the stories that bring math alive for the students? But then the organizers, they kind of sneaked in lots of other things also, like, for example, how can we make students more curious, and how can math help in the other side of the brain, like math and science is the logical side, and how can you develop the other creative side, which is reading and writing and other things. So I'll begin with the disclaimer. I will not be able to answer all those questions in 30 minutes, but I'll just take one topic, that is stories in math. So that's what today's talk is going to be about, unspooling the story of math. So when I knew this session was going to be after lunch, I thought I need to have some activity to energize people. But fortunately, you're all already charged up. But let me have this little activity for all of you anyway. So, can all of you show me 3 on your hand? Okay. Now, can you show me 3 with one hand, but in a different way? This. But I see more answers, like this. Can you find other ways to show 3? Yes, I am seeing this. One hand for now. Okay, this I have seen, this I have seen, this I have seen, this I have seen. Any other way we can show? Yes, I can see this. Very nice. Okay, so now we will make it interesting. Can you show 3 with both the hands? Okay, I am seeing this. I am seeing this. I am seeing what else? Yeah, I am seeing this. I am seeing this. Very nice. I am seeing this. But I am looking at the fingers. I am just counting the fingers. So now what are the different ways you can show 3 with fingers from both the hands? Yes, like this. Very nice. How many ways do you think there are of showing 3 with your fingers on both the hands? Huh? NC3. Who's that saying NC3? Okay, nice. That is correct. Can everyone else count the number of ways? Will it be more than 10, or will it be more than 30? Will it be more than 40? Okay. So now I'm not going to give the answer for this question. I would like you to go and work out for your own. Like with your 10 fingers, how many different ways you can show 3? So there are going to be 2 parts to this talk. That is with stories and math. One is going to be about math in stories. That is in fiction or in other places where math appears, where it is not a textbook. It's not a maths textbook, but somewhere where math appears. So we have math in stories, and there's a second part. That's going to be stories in math. That is in the history of math or while learning math. What are the different stories that come out? So, yeah. I want to present this activity as a kind of example how you can weave math and stories together. I have been in this event. I was here yesterday, and I've been here today. And when I meet a lot of people, they are very happy to see me. They are very happy to see that I'm a writer. But then when I say that I'm a math educator, everyone is kind of apologetic. Oh, I'm sorry, I don't like math. No offense to you. I'm sure like you're a very nice guy. You're a good math teacher. But I used to hate math in school. So now I just want to take this opportunity to show all of you. Problem is not with math. Math can be very fun. Math can be very interesting. And that is what I hope to show to you, all of you, in the next few minutes. So this is a story. The story is this. There is a king who has some horses. He keeps all those horses in a stable like this, where there are 8 squares, and he keeps 2 horses in each of the stable. Now this king, he's a very foolish king. He doesn't know how to count. So when he wants to count his horses, what he does is he walks around the stable. Along each side, he counts how many horses there are. So he walks on the top row, he sees that there are 2, 2, 2 in 3 rooms, so 6 horses. Then he walks down on the right side, he says, okay, there are 6 horses. Then in the bottom row, there are 6 horses. Then in the left side, there are 6 horses. Okay, so he has now counted how many horses he has. He has got 6 horses on each side. Now what happens? One night, a traveler comes to this stable. So this traveler has come far away, so he's very tired, his horses are exhausted. So he asks the stable keeper, can you please take care of my horses? Can you just keep it somewhere here for the night? Tomorrow I will leave. I will not bother anyone. I'll just take my horses and leave. The stable keeper says, I would like to help you, but unfortunately, if the king finds out that I've been accommodating other horses in his stable, he will take my head off. So I can't allow that. So the traveler says, okay. The traveler has 2 horses, which he wants to keep in the stable. The traveler now gives a solution to the stable keeper. He says, okay, what you want is, you don't want the king to find out that there are 2 extra horses. How does the king count? He just goes through each side and he wants to make sure that there are 6 horses. That is his. So now, if I keep my horses somewhere over here, so that there are 6 horses on all the sides, you will not lose your job. You will be fine. But I also want my horses to be safe. I want my horses to take rest. So as long as I am able to keep my horses in these stables, and on all sides there are 6 horses, like, you will be fine, I'll be fine, the king will not find out. So now, how is this traveler with 2 tired horses, how is he going to accommodate his horses in these 8 stables? And when the king, suppose he makes a surprise visit that night, still finds 6 horses on all the sides. Is it possible at all? Is it possible to accommodate 2 extra horses and still make sure that there are 6 horses on all the sides? Yeah, center room, I mean, there is no room in the middle. There are just 8 rooms around. So the center square is not open for us. You only have these 8 squares. Wait. I will try to take answers from everyone. So, I'll just go around the room. Yes, you had an answer? No, you can't take away any of the king's horses. Yes? Huh? No, you can't add a room. You can't, yeah, if the king finds out that there are extra horses, he's going to be very mad. If the king finds out that you have built an extra room, he's going to be even mad. So no extra room. Yes, you had a solution, sir. Yeah. Yes, remove corners and put it in the middle. Before I show you the solution, I want to share something else. So now, how many of you like this puzzle that you want to? Yes. If you walk along each side, there will be 6 along, if you add the rooms. Yeah. So, yes. First question is, how many of you like this question? How many of you think it's an interesting question? It's okay if you don't have the answer yet. That's okay. But how many of you like this question? Okay. Do you think this question can be put in textbooks for students? Okay. How many of you say no? Okay. Right. How many of you seen a textbook have a question like this? None of you have seen? Some of you have seen. The kids have seen. Okay. Yes. Yeah, someone wants to share something? Yeah. Okay. Right. So now, this is a question that's there in 3rd standard math NCRT book. It's there in a chapter called Fun with Give and Take. So you already have these very interesting questions in the textbook, in the mainstream curriculum. And yeah, the solution to this question is, of course, this. Yeah. So here's a solution where the traveler just rearranges the horses and now count how many horses there are in the stable. So there should be 12. plus 6, so 18 horses. So earlier there were how many horses? 16. Now there are 18 horses. Okay, so I just want to show this as an example of where you can teach math with some stories. Uh, Here, of course, the very simple operation that the students are doing is addition. They're just adding all the numbers to get the total. But then they are doing something even more. They are exploring, they are fiddling around with numbers, they are exercising their creativity and so on. So this is one example of a math problem which is woven into a story to make it more interesting, to make it more attractive for students. This is my favorite story. In fact, my student Vivan is also here, and we had discussed this particular example before. This is not fan fiction. It's an actual problem that occurs in one of the Sherlock Holmes stories. So there is the story called Musgrave Ritual, where Sherlock Holmes' friend kind of approaches him for a problem. That is, his butler is missing. And lots of things happens in that story, but here is the math part of it. Here's the problem that's actually there in the story. The story goes like they are looking for a treasure or something, and the treasure is buried under the tip of the treasure is buried at the tip of the shadow of this tree. So somehow they have this clue. So now they want to find out where the treasure is buried, but unfortunately, the tree is no longer there. The tree was hit by lightning several years ago, and they just cut down the tree. There is just a stump that is left. At 5 o'clock in the evening, where the tip of that tree, the top of that tree, where its shadow will fall. So this question is there in the story, and of course, Conan Doyle did not want to write a math textbook. So in one sentence, Sherlock Holmes solves this problem. But I'll just leave you with this problem for you to think about it for a couple of minutes. You know the height of the tree, but the tree is no longer there, and you want to know what will be the length of its shadow, where the tip of that shadow will fall, which is like finding what the length of that shadow is. So do you think it is possible to solve this? Sherlock Holmes does it in like a minute. He does it like very effortlessly. How would you do it?
So so at 5 o'clock where the sun is, you measure 64 feet in the opposite direction, and then the tip will be there, the tip of the tree.
What do you mean by opposite direction?
Like when the sun, say the sun is like in the left, yeah.
Okay. Fine. The sun is over here.
The sun is there, and when a shadow is created, it goes away from the sun, right?
Yeah.
So you can you know the height of the tree, so that's probably how long the shadow will also be.
So now will the length of this shadow be the height of the tree? How many of you think the length of the shadow will be the height of the tree? It's a good guess. It's a good approach that you've started with. It's a starting point. But now we will see if it's also correct. So how many of you think that will be the length of the shadow? That you can't measure 64 feet. This tree is no longer there, and you don't have a stick that is 64 feet long. But we can measure. Sure. But you can always measure 64 feet here. Will that be the place where the shadow? Very nice. Can you maybe repeat for everyone?
Yeah, just stand yourself at the stump and measure where your shadow falls, and you see how tall you are, and 64 feet is there. Multiply and get the number.
Exactly. So what Sherlock Holmes does is he takes a stick that is 6 feet long. He just plants it, and he finds out the length of the shadow of this stick. This stick, which is about this height. This is 6 feet long. It's like a fishing rod. And he finds out that the shadow happens to be 9 feet long at 5 o'clock. So now, if you know this, can you find out what will be the length of the shadow of that tree if it existed? Yes? Yes.
It would be 96 feet away in the opposite direction of the sun
Yeah,
because it's 1.5 times longer.
yeah, very nice. So this is exactly what Sherlock Holmes does. That is, he is able to measure the length of this shadow, and he immediately calculates that it is going to be proportional, and therefore the length of the shadow will be. Can you go to that slide? So the length of the shadow will be 96 feet. This is 6th standard and 7th standard math. So Sherlock Holmes is not doing anything extraordinary. Any 6th standard or 7th standard student should be able to do it. And all of us, I'm sure, have crossed 7th standard. But anyway, the point is, this is an interesting story. And when I first read it, I was really intrigued, like how Holmes was able to solve this. Yeah, I read it when I was probably in 6th or 7th standard. But wow, so I was very impressed with how Holmes was able to solve it. But this never appears in any textbook. What appears in the textbook is just find the proportion of these two triangles. You have this figure, 6 and 9. You have this figure. Now find the proportion or find the third side, whatever. Finding this third side is going to be Pythagoras theorem. That's also there in class 6 and 7. But the story is never there. And this, I feel, is kind of a shortcoming in the way that we teach math. And I feel, yes, so a lot of kind of antipathy towards math comes from our experience in our school days, where we were not told all of these stories. We were not presented math this way. We were just presented with some numbers. So, yeah, I just wanted to show that as a specimen, as a place where math appears in fiction. Of course, it is not meant to be a math textbook. It's not meant to teach math. So it is just appearing like one sentence, like a throwaway line. But how many of you like the story? How many of you would like to hear the story in your ratio and proportion? Okay, nice. Yeah, I'm glad to see some support for this. So now I'll go to the second part, which is about stories in math. So what I gave two examples were fiction, where we are introducing some math. So these are made up stories where you are trying to teach math. We have all of these made up stories in our textbooks also. So you have a question like, you go to a shop, one mango costs 10 rupees, you are buying 3 mangoes, how much does 3 mangoes cost? There is actually a very nice passage in the book Swami and Friends by R.K. Narayan, where there is this exact question. So Swami is sitting, his father asked this math question from the textbook. 5 mangoes cost 15 annas, how much is 20 mangoes going to cost? There they give the name of the shopkeeper, and Swami is thinking, are these mangoes ripe or unripe mangoes? So the shopkeeper is Krishna. Is this Krishna going to be like our shopkeeper Rama, who like cheats all the time? So this is what he is thinking, and he is not able to give the answer. And his father beats him, he twists his ears, and all of that he does. Finally, Swami gives the answer. That has been our experience also, where we also have these word problems, but these word problems are the worst. They are the worst stories to teach math. Fortunately, there are actually real stories in math, but which are kind of sidelined as a footnote. But these are like the most interesting stories to teach math. So this is one example where this is a real life story. I mean, now it has become a legend, so there's a lot of embellishment, but the story goes like this. In primary class, about say 200, 250 years ago, in a primary class somewhere in Europe, the teacher is, I don't know, kind of tired. He doesn't want to teach so much. He doesn't want to deal with so many kids. So he just asked this question, find 1 plus 2 plus 3 up till 100. And these are like class 1, class 2 kids. They just barely know numbers. They barely know to add. So the teacher is now giving this question, and he's happy. Okay, now the students are going to leave me alone for the afternoon. I can now take rest. So the teacher now gives this question. And in the class, all the students obediently start writing 1 to 100. They are calculating the total. The total is a huge number. You have 100 numbers, and you're going to add all of them. It is going to be a huge task, especially for young kids. But then in that class, one student, who is like maybe 6 years old, he comes to the teacher after 2 minutes and he says, I've solved it, now give me something else. So how can a 6-year-old answer this question in 2 minutes? Yes?
So write S1 is that, and S2 you write the same thing backwards. If you add the two sums, you'll get 101 plus 101 100 times. And you divide the whole thing by 2.
Yes. So the same thing I will present in a slightly different way. So what we will do, we will write 1 plus 2 plus 3 plus 4, but we will not write all the way till 100, but we will just write till 50. And then what we will do, we will write 51 here, 52 over here, and so on. And what will be the last two numbers? Yeah. So now if I add these two numbers, what is the total? I hope everyone can see. I'm not sure if people at the back can see. Like is it visible to people on this side? Okay. Maybe you need to come a little bit over here. Is it visible to everyone now? Okay. So now what is 1 plus 100? What is 2 plus 99? What is going to be 3 plus 98? What is 49 plus 52? And 50 plus 51? Okay. How many times do we have 101 appearing here? Yeah, I have just written 5 times, but this 101 appears many times. It appears 50 times. So now can we find out what is the total from 1 to 100? It is just 101 into 50, which is 5050. So this was how a very young mathematician, Carl Friedrich Gauss, calculate the total when he was just 6 years old. Of course, Gauss then made many discoveries in math, many discoveries in science. If you open 11th standard or 12th standard textbook, every chapter in math will have a Gauss's theorem, every chapter in physics will have a Gauss's law. In magnetism, in physics, in optics, and in math, in number theory, lots of places. So you just type Gauss's theorem, Gauss's law, you'll have 100 results. Similarly, there's been another very prolific mathematician named Euler, who has written so many books and so many papers that even now we don't know what all things he discovered. People are still translating and decoding whatever he has discovered. So this is a real life story, but we don't get to see this story in math. This story in math is there in the textbook, but it is relegated to a corner. So instead of this, you just have this question, like what is 1 plus 2 plus 3 up till 10, or some random 5-digit numbers. So these are real stories which will inspire students about math. And yeah, and how much time do I have? Okay. So there are other stories in math, but things which are like very obscure that we don't hear about them at all. So in our Indian textbooks, there is mention of Aryabhatta and Brahmagupta, who have made like really profound contributions in math. But now again, these are also relegated as side notes. We read Euclidean geometry, we read Greek geometry, and it's somewhere over in the corner it says, oh, but Indians also actually kind of discovered Pythagoras' theorem 2000 years before that in Sulba Sutra. So unfortunately, what has happened is Vedic maths has become a fad, which talks about fast calculation. So fast calculation was also a very integral part of math that was traditionally taught in India, but there is a lot more to it. But the way today Vedic maths is unfortunately taught is just about fast calculation. You have all these tricks to multiply 7 and 8-digit numbers. What is kind of missing is that Aryabhatta and Brahmagupta, they lived many years apart, but Brahmagupta is like a fierce critic of Aryabhatta. Aryabhatta was a kind of a rebel in his time. He did not like the way astronomers calculated the movement of the planets. He said, this is rubbish. I will now calculate it in a different way, and he gave accurate results. So he calculated the value of pi to something like 18 digits or something like that, which is like phenomenal. And he divided the yugas in many different ways. So he is thinking of like at an astronomical scale about how to divide time. And he was rejecting what was at that time the established convention of Indian math. And then several years, maybe centuries later, Brahmagupta comes and says, what Aryabhatta has done is wrong. His observations are wrong. Now we have better observations in astronomy. And he kind of like calls Aryabhatta with lots of very dirty names. He says, don't listen to this devil. He doesn't know anything about geography. You should now follow the tradition and this way. But we don't get to know all of these at all. So now Aryabhatta died many years before Brahmagupta came and criticized him. But Aryabhatta's school of math was still there. Many years later, someone from Aryabhatta's school will come back and criticize Brahmagupta. And Brahmagupta's disciples, several generations later, will come and criticize Aryabhatta's disciples. So there were actually these kind of rivalries in Indian math. Nobody in ancient Indian math just took math as kind of gospel, like it's a divine gift from God, there's nothing to do. Indian mathematicians were doing a lot of observations, coming up with new patterns, new theorems, and so on. But we don't get to know all of this. All of this is put under one bucket called ancient Indian math. There were lots of ancient Indian mathematicians like Aryabhatta, Brahmagupta, Bhaskara, and so on. So the Pythagoras theorem is actually discussed in Sulba Sutra. It starts with this question. You have two squares. Can you make another square whose area is the sum of these two squares? That is how the problem is presented, and they also give a solution and so on, but yeah, I'll not go into that. Then in kind of few recent years, there was this great rivalry between Cardano and Tartaglia. So what happened in 16th century Europe, specifically in Italy, was they had these very powerful merchant cities, Milan, Venice, Florence, and so on, and they will set up their own university, and like it will be their fiefdom, and they will have rivalries across these different cities, across different universities. So at that time, solving a cubic equation, that is like equation of the form x cube plus 5x square plus 3 or something like that, was impossible. At that time, they didn't know how to do it. So now what they would do was, someone would claim from one university that I have solved it, I have a method that will solve. And he will issue a challenge to another university. You give me any equation and I'll give you the solution. So now people from the other university, Florence or Venice or somewhere, they will say that no, I will challenge you to solve this. They may or may not solve. So then they will issue a counter challenge. So now these kind of rivalries will go on for several decades. And there it was like whoever has the formula to solve a cubic equation or a biquadratic, that is the degree 4 equation, now they have the upper hand in the sense that they will be the best center for learning maths. This rivalry happened for several years, and in more recent times there was this rivalry between Erdős and Selberg. This is actually a very interesting story in the sense that Erdős was a prolific mathematician in the sense that he has published thousands of papers, worked with hundreds of mathematicians over something like 4 or 5 decades. He started when he was a child prodigy, and like he started when he was 18, and he worked in maths till maybe he died in like some 80, when he was 80 or 90 or something. He has like thousands of collaborators. He is a very charismatic personality. He travels around universities. Reportedly, he never stayed in one place for more than 1 month. So he would just go to universities across the world, schools across the world, primary schools across the world, and just teach math to kids of all ages, like from primary up till graduate or like doctoral level. And while he was traveling, he would like come up with lots of these incredible theorems. And there was this another mathematician called Selberg. He was a Norwegian. And the two of them were working on what was at that time one of the hottest problems in math. And now what happened, they both collaborated and they both got a partial solution. Now Selberg is a Norwegian and he's a very reclusive guy. He doesn't collaborate with anyone. he doesn't like fame, fortune, or anything. Yeah. So now what happened was, when they had the partial solution, Erdős quickly went out and he published his result, which was kind of their collaborative work. And Selberg did not even know about it. Like, he didn't read newspaper, he didn't read journal or anything. And the next day, like, the newspaper headline is, Erdős has solved the problem. And Selberg is now like furious. Like, we both worked on it together, but because you have lots of friends, you got it published. And yeah, so they were not on speaking terms for many years. Now, these are not like made up stories, these are real life stories. Yeah. I'll just quickly wind up because we're running out of time. So some of the issues with the stories are, number one, they kind of project this myth of an eccentric genius. So you have stories about Ramanujam, who is this brilliant guy who is like way ahead of his time and so on. And then you have Gauss, who is like this guy who solves this problem in 2 minutes when he was 6 years old. Now, what it creates this illusion is that you either are this God-given, you either have this God-given gift, or you are not a math person. You can either be a math person or a non-math person. So unfortunately, it's not true. Math is just like any, it's a skill, like anyone can pick up. But the stories we tell often have this kind of a tinge to it. Next slide. And many of our stories tend to be kind of Eurocentric. We talk about European mathematicians because, I don't know, for many reasons. But there are lots of interesting biographies, there are lots of interesting stories about Indian mathematicians also. Unfortunately, I guess like some mathematicians have this celebrity status. Ramanujam, he's a brilliant mathematician, but yeah, he kind of dominates the story about Indian mathematicians. Yeah. So the takeaway for all of you is this. Stories are useful for teaching math, but I will not claim them to be a magic bullet, that if you have stories in math, suddenly math becomes interesting. No, but it's a very useful tool. It, along with games, puzzles, and hands-on activities, lots of other things, they make math more interesting. And unfortunately, the way that we teach math lacks this story. So for parents, this is what I want you to take away from these 30 minutes. Marks don't measure anything, so don't judge your child based on the marks they get. Unfortunately, the questions that we give in math are not so interesting, so it does not measure anything. Marks are not so useful. There's this one question which I get from people all the time, that where is the math that is useful? The horses story, for example, none of us own horses, none of us are going to build stables, but it is still worthwhile, it is still worth thinking about. And for the teachers, I would like to say that textbook is not a scripture. People have never treated it as such. Mathematicians have never treated it. Textbook is just a guideline. So don't see what is there in the textbook, in the exercise problems, the word problems, and think that this is math. No, this is just a very tiny fraction of the math. And for publishers, if you are sitting, there is brilliant content. There is like amazing content that is out there, but which is packaged poorly. When people are told that here is a math book, people want, like, after you read it, you should become a math genius, or you should learn something. Unfortunately, that is that mindset, but there is a lot of good content that requires good packaging, and there it's like publishers have to come forward and create good math books. And yeah, the last slide. So, the last statement that I want to make, the last slide is, math is not about numbers or formulas or theorems. Yeah, math is about patterns, reasoning, and creativity. And stories are a good way to bring out these aspects of math. So that's it for today. I will conclude this session. Thank you for listening.